How many of you have heard of cross-stack references in CloudFormation? Cool. So you saw how I generated the output, how I spat out my API URL in my beta CloudFormation stack. Other CloudFormation templates can reference that URL if they have to. Possible can be helpful, but if you truly do want to keep your services separate and isolated, your service should not depend on his DynamoDB table or his S3 bucket. Or if it really has to keep it to a minimum. They should be talking by APIs, and I think I can rant about that for a while, and I will towards the end of the session. But my point was keep it self-contained. So the next one is one that comes out a lot recently, multi-region. How do I deploy my stack to multiple regions? It's difficult. We have a fairly hacky way to do it. A lot of customers have asked for it, so it's definitely on our list. But I'll walk you through what we ended up doing with some of our customers now. So first, why is it difficult? It's difficult because API Gateway, like I mentioned earlier, uses CloudFront. And what that means is that we need to control your DNS records because we need to route to all the various pods. And CloudFront and Route 53 only allow a single owner of a domain across the world. So if we take it over, you can't control it. And that means you can't have your own Route 53 records and configuration. So what did we end up doing here? Is this is our hacky solution. So don't give the domain name to API Gateway. Keep the API Gateway's default domain name that executes API blah 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 .amazonaws.com. Create your domain in Route 53 and create a few text records inside that domain, one per region where your API is. The value of that text record in the DNS is the endpoint of the API Gateway API. And so what happens is when the client starts, it basically makes a dig or queries that DNS and say, hey, give me the text record you have. Route 53 is configured to do latency-based routing. And we'll say, oh, you're there, so this is the fastest text record for you. And then the client takes the API endpoint out of that text record and uses it to initialize the SDK. It's pretty hacky, but we'll go over it. The alternative would be to have the region name as a subdomain in the API endpoint, in the API domain, which works too, but it doesn't get rid of the fact that then the logic is still in the client. Still the client that decides which region to talk to. So one way or another, you can't get away from that, at least for now. So let me show you how this is set up in my Route 53 here. So I have my hosted zone here. It's a domain I own. And here you can see I have the main domain, but then I have two text records for my API subdomain. And the text records are configured with latency-based routing, one per region. This routes based on latency to AP Southeast. And this one to US West. And so all your client does is literally, if you're familiar with Linux, dig this text record, dig against this domain. And I've set up a couple of EC2 instances, one in the US West and one in Sydney, AP Southeast 2, to test this. And so I'm going to go and SSH, let's start with US West 2. And here, I'm going to do a dig against that. I'm going to do a dig to get the text record out of my API domain. And you can see that this responded with the value of the text record. So all the client does after this is get the URL out of there and use it to initialize the client SDK. And this is pointing me to my US West 2 API. If I were to go out now and let's go over to Sydney, which I'm sure I have here somewhere. Yeah, these two. And we make the exact same dig to the exact same domain. It comes back with the same text record, but this one is pointing to my API deployment in AP Southeast. So it's a little bit hacky, but it does work. And it's the best solution we have right now to do multi-region. As I said, we hear you working on it, but this is what you can do right now.
Do you have an idea of what the workaround will look like? Can you think about it? What the new solution for this will be?
The new will probably we really want to give you control of your DNS record, so you can do whatever happens. So that's what we're looking at. That's what we'd like to do in the end. But this is workable. It involves some logic in the client, and that's not ideal. But the truth is that we'd always recommend you keep your services regionalized. One region shouldn't depend on another. And as you fade over from one region to another, you'd still want to have some logic in the client, because switching to DNS works, but it's not instant. So the client should still know that I ain't getting anything here. I should go to the other one. So some of that will stay there. So I'm done with the demos. Now I can just rant about stuff. Yeah, sorry.
Do you have client-side sample code or open source libraries that do that in order based on the DNS records?
No, I do not, but I will publish it. I can publish it on a Git on GitHub, and you can get it from there. There's lots of libraries to just do DNS queries. All you're doing is querying the DNS for your domain and getting the text record value out of it. This one comes up a lot. Customers start adopting Lambda, and the assumption is, I am using Lambda, therefore I am building microservices, and I am at the cutting edge of technology. Not quite, and I always answer this question with another question, which is, why are you building microservices, or why are you obsessively building microservices? So I have 3 tenets that I think about when I build microservices. Obviously, decouple components. That's why I wasn't a big fan of cross-stack references earlier. Ownership. One team owns one service. They are responsible for operating it and all its dependencies. And finally, they will hopefully allow you to get to market faster. And I know there's a lot of arguing here that very often the argument is, well, if you're a small startup, microservices are hot, you'll try to build it, but you really shouldn't have to. It's something that you will get to when you get much bigger. But unfortunately, a lot of customers say, I'm using Lambda, therefore I'm building microservices. And this is what I end up with. This is what they show me. It's a Lambda function that pushes to a Kinesis stream that's consumed by another Lambda function that goes to another Kinesis stream. That's then another Lambda function that goes to SQS, and then that's consumed again. And this fails all of the tenets. All of the 3 tenets we set out earlier. They're not decoupled. They depend on each other. And they depend on knowing what each other spits out and consume. If they're separate teams, multiple owners will be working with shared components. Those Kinesis streams could be owned by one or the other, you never know. And ultimately, you'll wind up deploying it as a monolith. Because if I change the output of Lambda function 1, I will have to change the way Lambda function 2 consumes it. And so really what we're doing here is making the enterprise service bus great again. And try to replicate that in the world of Lambda, whereas when we look at it, and this is something very real I looked at, is there's some clear delineation there. Why are ingestion and sanitation communicating via Kinesis stream? Why aren't they the same thing? The truth is that you have the Kinesis stream in front of ingestion. That's where you want your buffer. That's where you want to be careful and know that you can accept as much data as you need anytime. But then ingestion and sanitization can be the same thing. And then we have metadata. We have a function that just attaches metadata. that metadata can be very useful. And guess what? Maybe in the future you'll start ingesting from some other source, and you will reuse the same metadata. And if you see that happening in your future, then it makes sense to have metadata as its own service, with its own API that just does CRUD. The ingestion sanitization goes there and asks it, hey, have you got metadata for me? And so service 2 in the future can do the exact same thing. And then caching, that can go to the front end. That could be an event, or the front end itself can pull from the metadata service and then hold it there. And they need to be completely separate. I think my biggest point here is that they should communicate via APIs. Sure, Kinesis is super helpful there to ingest data if you have a big burst. It's very scalable. But it should have an API in front of it. You should own the contracts between your various services. You can trust AWS never to change an API or make a breaking change, but that doesn't mean that it's a good reason for AWS to own the contract between your services. You want to own that. Now, I have a vested interest in selling API Gateway. That's why I've got the API Gateway logo there. But I'm trying to make a broader point. For all I care, this could be a tiny EC2 instance running Express. The point is you own your contract. Does that make sense? Yeah, sorry.
I got a question for 2 slides back.
Yeah.
If you replace all those Kinesis streams with state changes for your step function, does that look like a step function? It's looking a lot like a lot of the step functions I made.
It's something that could be a step function. Yeah. It could be. It depends. For example, the attached metadata there could be a separate service and could be. The point why I separated it is because I wanted it to be queried by both sides, from both sides. I wanted the ingestion service to query it if it needs it, and the front end on the other side where it goes and populates the cache, that service receives a request, and then and only then goes and queries the metadata service. No point in pushing everything to a cache just because, lazily loaded. But yeah, absolutely, it could be a step function. And then your only question is, who owns it? Is it one team that does all of this? Then yeah, absolutely, could be a step function. If I have a separate team that manages the metadata and a separate team that manages the cache, then it could be harder to get them to work together in a step function and publish it. But yeah, this could work either way in this particular example. So takeaways, like I said, I want you to own the contracts between your services. Don't give them to anybody else. Make sure that teams can operate independently. Don't tie them together because you'll just reduce your velocity. And don't depend on somebody else's implementation. And this is what I was saying. Yeah, Kinesis, great to use. But the fact that you're using Kinesis shouldn't be your customer's problem. They shouldn't have to learn to talk to Kinesis. There should be your API in front of it. Make sense? So this is a big topic. How do I test my functions locally? And how do I do local testing and local development of Lambda in general? Truth is that we don't have a super great answer right now. Lambda runs on Amazon Linux. That's pretty well known, and the AMIs we use are public there in the Lambda documentation. Can I emulate Lambda in local? Yes. We don't help you with that. we publish the AMI IDs, and we run Linux containerization. You can emulate that. What will be harder is the context and the event. Now, fortunately, the community has stepped in, and there's a lot of third-party frameworks that help you do exactly this. For Node.js, there's something called Lambda Local is the most popular. Python Lambda Local and AWS Lambda Local Runner. Java people always like the longest name. But yeah, there's lots of packages that make it very easy to emulate Lambda in local. And they do a pretty good job at keeping up with API changes and Postgre object changes. Now, what if I'm building an API? Here I have a few more opinions. We have a couple of open source libraries in the AWS Labs account called Serverless Express and Serverless Java Container. What did I tell you about names? There's no API gateway local, but what these libraries allow you to do is take an existing Express application, or Java if you've written it in Jersey, Spring, or Spark, and run it inside Lambda. There's multiple benefits to this. One, you keep writing code exactly as you used to. Second, you can start the embedded container. You can just go Spring Boot start, or Express start in local, and do your own test. The library then is just a very thin wrapper around your application. So if you're, and thirdly, it allows you to port this application wherever you need. You can run inside Lambda if one day you want to use ECS or EC2. Take the exact same code and start it there like you would have if you were writing Express apps normally. So if you're writing APIs, I would definitely take a look at these libraries. Has anybody tried them? Oh, you have. Thank you. 1 minute. I hate when I talk about a slide before I get to it. But yeah, I would say portability is important, and keep writing code like you're used to. You don't need to change your tool set and your mindset because it's Lambda. You can keep writing Jersey applications just like you were doing before. What do you guys use? Do you guys use any frameworks, any libraries? How many of you use the serverless framework? Chalice? No Chalice? Oh, James upstairs is going to be disappointed. Check out Chalice for Python. Last topic, and then I promise I'll stop because I'm way over time. I get this question a lot. Can API Gateway do all? And I don't know what that means. I think we need to start from the beginning and say, what is OAuth? So OAuth is an open standard, and it defines an authentication flow. It's a flow. There's no hard requirements around how it should work and what it should produce. So it's not an API. It's not something that we can necessarily standardize around. OAuth 2 is a lot better than OAuth 1, but nevertheless, it's something that involves an authentication flow. And the outcome of that is what matters for your APIs afterwards. And to make it easier, this is an example of what OAuth is. This is the conversation flow defined by OAuth. Joe, the user, goes to Bitly and says, hey, I want to publish a link to my Twitter account. Bitly say, great, let me go to Twitter and tell them that I have somebody who wants to publish, that wants me to publish to their account. Twitter says, well, good, here's a token that you can use to come to me and ask for authentication. Bitly, who's the provider, sends Joe, the user, to Twitter so that it can authenticate. The user enters the username and password. Everything goes well. Twitter sends it back to Bitly with an authorization code so that Bitly now can make API requests. This is everything that, this is what OAuth says. There's no hard spec in there that says, this is what the token should look like. This is what you return. So there's nothing that we can easily implement to support this. And so to answer your question, do we do OAuth? No, not really. And it's not API Gateway's job to do OAuth. API Gateway is not an identity provider. We don't have your user database. We cannot authenticate your users. Cognito does. That's a great tool at AWS to do that. Cognito user pools, and recently they launched in public beta the support for a couple of the OAuth 2 flows. So that's something you should look at. But as far as API Gateway is concerned, all we care about is that we can verify the bearer tokens that are the outcome of an OAuth flow and the authentication flow. And a final note to this is a lot of people mention OAuth and they want to build OAuth. You shouldn't really look at OAuth unless you're planning to build an ecosystem of third-party developers that allow your users to interact with your APIs via their application. If you don't have a requirement to do that, all you achieve by creating an auth implementation is to make your attack surface larger. There's a lot of very well documented security flaw in auth. It's just the best solution we have so far for this problem. So unless you absolutely need it, I wouldn't implement the auth flow. And a classic example of this is that auth says that you send the access tokens as you redirect people in the URL as query string parameters. Which makes sense, it's a web server, you can only accept gets and it needs to go into query string parameter. But guess what? Query string parameters in URLs are not encrypted even over HTTPS. So anybody can snoop that traffic, get your tokens, and make call on behalf of somebody else. So unless you absolutely need it, I wouldn't go and implement it. This is it for today. A couple of notes. I'm going to go to the next slide and then come back. Next week, very interesting meetup from a customer that's going to tell you how they build stuff. So I would definitely look at attending this. Let me know when you have the picture, and I'll go back to the one with a link to the code.
I have a question.
Yeah.
Related to your previous slide. So not exactly go off, but one of our use cases is deploying internally available database, which is kind of a challenge in the internal subnets. Is there anything on the radar to have database internally available or in the context of VPC?
So yes, a lot of customers ask for that. So yeah, it's definitely on our list. What is your use case? Is the gateway still public? So are the APIs public facing, or is everything private?
Gateways to be
Internally facing your gateway. So yeah, that's also a use case that's on our list. What I tend to see very often now is when customers want to make APIs private, they tend to set up API gateway to use IAM auth. And when you use IAM auth, somebody needs to have AWS credentials to call those APIs. And so yes, the endpoint is still public, so you still have that risk. But beyond that, the risk is the same as you losing your AWS credentials and somebody accessing something else. So that's the pattern I've seen the most right now. Do you guys know how?
Is that on the radar though? Is that?
Yeah, totally.
Yeah, I know the workaround.
So the ability to have API gateway public and backend private, and API gateway private and backend private are both very, very highly requested. So they're definitely on the list. Do you guys know how AWS IAM SigV4 all works with API gateway? How many? Okay. So do you know what SigV4 is? So SigV4 is how AWS authorizes calls. That's how we authorize calls ourselves. When you make a request to an AWS service, like DynamoDB or S3, you sign that request. It's an HMAC signature based on the credentials we gave you. The access key, secret key, and session token if they're temporary credentials. And what's special about API gateway in this case, and I'm going completely off script, guys, I'm done. If you need to run. What's special about API gateway in this case is that it treats your service, your API, as if you were an AWS service yourself. So when you create an S3 bucket or start an EC2 instance, you get an ARN for that resource, right? That unique identifier for the bucket or the instance or everything really in AWS. So API gateway gives you a unique ARN for each method in your API. So the get to /photos has its own ARN, so does the post, etc. And what we can do there is that we can accept signed requests, just as if they were signed to an AWS service on your behalf, verify that signature, and then you can use your IAM policies and users to say you have access to this API endpoint, you don't have access to this API endpoint. So it's very common for people who want to make stuff private or that can only be accessed from an EC2 instance. They set those permissions in the instance profile. And then the client on the instance can only call those endpoints. Cool, guys, I'm done. I'm going to leave this URL up here, just in case you haven't seen it. Thank you very much for coming.
hopefully it was good despite the Wi-Fi fighting me a bit.